Okay, so now that we know a lot of information about the subatomic particles of atoms and elemental symbols, it turns out that very easily, if we know a little bit of information about a given atom, we can infer a lot of knowledge from that information. And we'll illustrate that with this following example. Okay, for the first part of these scenarios, we're going to be looking at neutral atoms. And so neutral implies that there's no net charge. So what that really says is that the number of protons will equal the number of electrons for an atom. Okay, so if we know for the first example that this atom has 6 protons and it's neutral, it therefore has 6 electrons. Okay, we know that the atomic number Z is equal to the number of protons, and if this atom has 6 protons, the atomic number is 6. If this atom has 6 protons and 7 neutrons, it there of course has 13 for a mass number. Okay, and so what we would want to do is we want to show this carbon 6 is of course carbon, atomic number 6 equals a carbon atom, and carbon 13. Okay. If we have an atom with 42 electrons and a mass number of 96, we can figure everything else, of course, out. 42 electrons would imply that this has 42 protons if it is in fact a neutral atom. 96 and 42 would be a difference of 54. So 54 and 42 equals a mass number of 96. And, of course, if it has 42 protons, its mass number is 42. Atomic number of 42, if we look at our periodic table, we'll see that that is a molybdenum atom, MO, and we would write the symbol 4296. If we're given all this information about aluminum, its atomic number and mass number, we can therefore, of course, figure everything out. Atomic number 13, mass number 27. Atomic number 13 gives 13 protons, and a neutral atom would have 13 electrons. The difference of the sum of the protons and neutrons equals 27, so 13 plus 14 would equal 27. Alright, for our last example of neutral atoms, if we have an atomic number of 55, that of course tells us we have 55 protons. Neutral atom would also have 55 electrons. And then, of course, the sum of the protons and neutrons equal 133. So 133 minus 55 equals 78. And an atomic number of 55 tells us that this is a cesium atom. Atomic number 55, and this isotope with a mass number of 133. Now, it turns out that we can also have atoms with a net charge. And those are, of course, not neutral atoms, and therefore we call those ions. Okay, so ions are atoms with a positive or negative charge. Okay, it turns out that this can also occur for molecules. Molecules can have positive and negative charge, and we'll call those polyatomic ions, and we'll see those in a few video lectures. But how do we get to the formation of ions? And in chemistry, chemical reactions will form ions from either gaining or losing electrons. Okay? So a positive ion implies that the number of protons is greater than the number of electrons. And again, in a chemical reaction, all we're going to be able to do is gain or lose electrons. We're not going to change the number of protons for a given atom. Of course, that would change the element. So, if we have more protons than electrons, that means a neutral atom has lost an electron. Okay? It turns out we can lose one or more electrons to form differently charged positive ions, and we'll see examples of those. So, for instance, we could have a sodium atom with a neutral charge. It could lose an electron to form a sodium plus 1 electron, or excuse me, ion. And we would write that loss given written like this. Okay. Turns out some atoms can lose 2 electrons, such as magnesium, to form a positively 2 charged ion by losing 2 electrons. Okay. Now it turns out that most positive ions are formed from metals. Okay. Metals tend to lose electrons to form positive ions. And we also have a name for positive ions, and we call them cations. So we would call sodium neutral an atom, sodium +1, that is a cation. Okay? On the other side of the coin, we could have negative ions, and that implies that the number of electrons is greater than the number of protons. And for this to happen, of course, that would imply that the atom has gained electrons. Okay, so we could have a neutral fluorine atom plus 1 electron, and that would produce a fluoride ion with a -1 charge. Oxygen atoms can gain 2 electrons to form ions with a -2 charge. Okay, and as you can see, I've been writing the charge in the right superscript next to the elemental symbol. As you probably heard me say, when elements gain electrons, we actually change the name of the species. So we change names for negative ions. And what we do is we change the stem of the name and we add an IDE. So fluorine became fluoride, oxygen became oxide. Add the IDE to the end of that name. Okay. Just like we had a name for positive ions, we have a name for negative ions, and we call those cations, or excuse me, anions. And if metals tend to lose electrons and form cations, it also turns out that non-metals tend to form anions, so non-metals tend to gain electrons. Okay. Given this information, we can do a very similar exercise with atomic ions. If we're going to have a little bit of information, we can infer the rest of the information with our knowledge of atomic numbers, charge, and symbols from our periodic table. So if we're given an example of something with 16 atomic number and 18 electrons, the atomic number tells us that this ion has 16 protons. If you have 2 more electrons than protons, you have a -2 charge, and an atomic number of 16 implies that this is a sulfur atom, and if it's an ion, we would change the name to the sulfide ion with a 2- charge. Our second example gives us 12 protons. We of course know that would give us an atomic number of 12. If we have a +2 charge, that means we have 2 more protons than electrons, so that would give us 10 electrons. And the atomic number of 12 tells us that this is a magnesium cation, just like we saw, gaining 2 or losing 2 electrons. Excuse me. An aluminum +3 cation, of course, tells us that that is a 3 positive charge. We can look at the periodic table and we can tell that the atomic number for aluminum is 13, implying that it has 13 protons. And if it has a 3 positive charge, that means it has 3 more electrons, or excuse me, 3 more protons than electrons, so 10 electrons. And our last example, if we're given that we have 36 electrons and a -1 charge, that implies that we have 35 protons, 1 less proton than electron. 35 protons give us a atomic number of 35, and that of course is the bromine atom, and if it is a -1 anion, that is the bromide anion.